data rate depends on the mainly on three factors. In that, the first one is bandwidth available. Okay, the bandwidth available. So what is the bandwidth of the channel? Okay, so based on that you can decide what is the data rate. Then level of signals we use. So what are the how many levels of signal transmission you are using? Is it 2? That is L value. Okay, so you should be able to tell what is the number of levels used. Then quality of the channel. Okay, so that means how much noise it is there. So that is also going to disturb the data rate. At what fast it can send the data in terms of bits per second. Okay, so it is going to affect based on all these three factors. Is am I audible now? Am I audible?
Yes, ma'am.
Oh,
Yes,
oh,
ma'am.
okay, fine, thank you. So we have two theoretical formulas. Okay, so one is for noiseless channel and one for noisy channel. So always remember these two terms. Noiseless means where we are considering so noise of the channel is 0. Okay, noisy channel means there will be some amount of noise when the signal transmits through the media. Okay, for that they have given two theoretical formula using Nyquist. Nyquist for noiseless channel. Okay, it is one of the scientist's name. He has given this. There is a formula to calculate what is the data rate if it is a noiseless channel. Okay, and we have another formula that is Shannon. Shannon formula that is used to calculate the data rate for noisy channel. Okay, so these two formulas are very important. Okay, you may get some problems on these formulas. So at last we'll conclude. So which one we need to follow? Is it we have to go with the Nyquist or we have to go with the Shannon? Okay, so we cannot go any one individual. So we'll just conclude it. What we need to go with these two types of channel. So which one we need to consider to measure the data rate of the channel. So now the first one is, I think yesterday we have already started this noiseless channel, Nyquist bitrate. So this is mainly for noiseless channel. So for this they have given the formula that is bitrate. Bitrate is equal to 2 into bandwidth into log L base 2. Okay. So we have already bandwidth indicates bandwidth of the channel where L indicates the number of signal levels used to represent data. Okay. Number of levels. You are using two levels of representing the signal. So that is just a voltage, variation of voltages. How many levels of variations of voltage you are using to represent the signal. Then bit rate is nothing but bit rate. So that is measured in terms of bits per second. How many bits sent per second. Okay. So this is the formula yesterday we have already discussed. And yes. Any doubt? Okay. So if and here we need to understand that so by just keep on increasing the L level, so there is no possibility of keep on increasing the bit rate. Okay, so it may when you just keep on increasing just to increase the bit rate. Okay, what happens is at some point of time there will be a reliability problem. Okay, once it reaches at the receiver, if the number of levels are increased, okay, it is keep on increasing. What happens? So it is going to difficult at the receiver side to decode it, to understand. Okay, due to that there may be loss of data also. So this is not going to ensure. Okay, because you can just see so bit rate is directly proportional to the signal level. So just thinking that you cannot go for keep on increasing the level, there should be some limitation, some threshold value should be fixed for L. Okay, so we have discussed 2 level 4 64. Okay, if it is still going on more, okay, it is going to be like error is introduced in the signal. So there may be possibility of that. So due to that, reliability cannot be ensured. Okay, so we have discussed the problems also. So how to calculate when they have given the bandwidth of the channel. See, bandwidth always measured in terms of hertz. Okay, there are two contexts we'll be discussing today. So in one context we'll be using BPS, in another context we'll be using hertz. Okay, so here they have given the bandwidth, substitute the bandwidth, and number of levels, it is 2, substitute L value. So you're going to get the bit rate. And also in other problem, so where you need to calculate the, so this is also similar. This is just you need to understand the comparison. You just observe. So I have just same bandwidth, okay, same bandwidth. The L value is increased by 2. Okay, it is increased to 4, 2 to 4. You just see what is the bit rate. So here 12,000 and here it is 6,000. Okay, that means if you are keep on increasing the L value, bit rate is going to increase, but you cannot go for behind the threshold value. It is going to lose the reliability. Is it clear? So this problem to ensure that how L is related to bit rate, signal level. See, if I'm going fast or if you're not understanding, just interrupt me in between. And this is to calculate number of levels. Okay, they have given the bit rate and also they have given the bandwidth. You need to calculate the L value. Okay, so here we got 98.7. So always L will be represented in terms of power of 2. Okay, so in that case either it will be 2, 4, okay, 8, like this. You cannot represent 98.7 levels. So either in this case the level should be increased or it should be reduced. Okay, you're just getting some approximate value of L. So if you have 128 levels, the bit rate is 120 kbps. If you have 64, then bit rate is 240 kbps. Okay, you can calculate that correspondingly. You will come to know what is the bit rate for 64 and 128. So it is in kbps, kilo, 10 power 3. Okay, so that is for noiseless channel. Okay, noiseless channel, remember the formula. So that is a bit rate. Formula is very, very important. Bit rate is equal to 2 into bandwidth into log L base 2. Okay, this is the formula for noiseless channel given by Nyquist, or we call it as Nyquist formula. Okay, if they given any problems like this, you can just use this formula and calculate. And just observe the key term. Either you should have a Nyquist term or it should be noiseless channel. Then only you can use this formula. Okay. And also the one more indication is if they have given number of signal level. So in that case you can use the formula and calculate for what is the bit rate for noiseless channel. So next we'll move on to noisy channel. Okay, noisy channel. So it is given by Shannon. So it is called as capacity, Shannon capacity. So how it is, what is the capacity here? So it is nothing but once again the channel capacity. I am talking about the channel capacity. Because why they have introduced this formula? Because in real time we cannot have a channel that is noiseless. Okay, so definitely there will be some noise added to the signal. So for that reason, so this is the formula used for calculating the, see, these are all just theoretical, that means it is not practically implemented. These are all just theoretical formulas. So what is the data rate? Okay, or we can represent data as a capacity. Capacity is equal to bandwidth into log 1 plus SNR base 2. Okay, so why SNR? Because we are considering noisy channel. So you need to know what is signal to noise ratio. Okay, so using that SNR, you will be able to calculate what is the capacity of the channel or what is the data rate of the channel. Okay, so here bandwidth of the channel. So bandwidth indicates bandwidth of the channel. SNR indicates signal to noise ratio. capacity indicates the capacity of the channel bits per second. Okay, this is in terms of bits per second, how many bits sent per second. Okay, so in Shannon formula there is no indication of signal level. Okay, we don't have any L value here. So which means that no matter how many levels we have, we cannot achieve data rate higher than the capacity of the channel. Okay, so that is so simple concept you need to understand is, so it cannot go behind the channel capacity. So if you just keep on increasing the L value 64, 128, okay, there will be some limitation for the channel bandwidth. It cannot go more than that. Even if you are increasing to higher values of L, so there is a limitation. Okay, how much it can send, it is limited to that. So for that reason, in Shannon capacity formula, so they have not considered the L value. Okay, so we cannot achieve the data rate higher than the capacity of the channel. So how to calculate the capacity? So the capacity is equal to bandwidth into 1 plus SNR log 1 plus SNR divided by base 2. So we'll try to solve. Is that clear now? What is noisy channel and noiseless channel? For noisy channel, we are using Shannon capacity to calculate what is the data rate. So we'll go through some of the problems. Okay, so the first one, don't see the solution, first understand the question. So consider an extremely noisy channel in which the signal to noise ratio is almost 0. Okay, so that means they have given it is a noisy channel, but here the signal to noise ratio, it is very negligible, it is almost 0. Okay, in other words, noise is so strong that signal is faint. For this channel, the capacity is calculated. Okay. So you just tell me, yesterday we were discussing with respect to SNR. What should be the SNR value? Is it should be low or high? Is it to tell about yourself? Okay. So you just tell me, is it should be low or high to tell the quality of the signal? What is SNR? SNR is equal to signal power, that is average signal power divided by average noise power. Okay, so now from this you can tell what should be the value of SNR. If it is low means what is the meaning? If noise is more, okay, the SNR value is going to be low. Okay, so it indicates the quality of the signal is not good. If it is noise is less, okay, noise is less, so you are going to get SNR value high. Okay, if it is high, the quality of the signal is good. So that you remember, that point is very, very important. So now you just go through the problem. So here they are telling signal to noise ratio is almost 0. Okay, so in other words, noise is strong that it is fainting the signal. So for this channel, the capacity is calculated. C is equal to, so this is the formula, then bandwidth 1 plus 0, just substitute SNR here. Okay, it is 0 and calculate. So what is the value you are going to get? Log 1 base 2 means, so you should write somewhere how to calculate log 2. Okay, in all the formula we are using log 2 base 2. So you're going to get 0. Okay, bandwidth into 0, you're going to get 0, the capacity, because the quality of the signal is not good. Okay, so there is more noise added. When more noise is added, it is fainting the original signal. So in that case, the data rate, it is going to be 0. Okay, so this means the capacity of the channel is 0 regardless of the bandwidth. Okay, so regardless of the bandwidth, whatever may be the bandwidth that is there, so we are getting the channel capacity is 0. So what is the meaning here? There is a more noise in the channel. So we cannot receive any data through this channel. Okay, so we can receive the data, thing is that is not the correct data. Okay, it is more noise added to the data. Is it clear? So these are just the important points you need to understand with respect to the formula. So next we'll move on to the second problem. Okay, so we can calculate theoretical highest bit rate of a regular telephone. Okay, so regular telephone, a telephone line normally has bandwidth of 3000 hertz. Okay, so this is the range they have given. So here we are going to consider 3000 hertz assigned to data communication. So the signal to noise ratio is 3162. So what is the channel capacity? So they have given the SNR and also bandwidth. Okay, just substitute it, you will get the result or the capacity of the channel. Okay, so if you want to increase the capacity of the channel more than this, so in that case it requires to increase the bandwidth. Okay, it requires to increase the bandwidth or improve the signal to noise ratio. That means you have to use some technique to reduce the noise in the channel. Okay, are you getting this? So the formula, it's very simple. I am not just writing all the steps. B log 2 1 plus SNR. You just, when you are solving, go step by step. Don't directly. So here they have given the bandwidth is 3000. Okay, log 2 1 plus what is SNR? So 3162. So now 3000 into log 3163 base 2. Okay, you just calculate this. So how will calculate this? Log 23163. So you need to just open your calculator and try to attend the classes in the laptop. Okay, I don't know how long you can see the slides in the mobile phone. Okay, you need to take log 3163, calculate this, and log 2. Okay, whatever the value you are going to get, it is 11.62. Just check it. Okay, substitute that is 3000 into 11.62. So you are going to get the answer 34,860 bps. Okay, so this is the answer. Okay, just don't directly write the answer. So now when you are seeing the solution, you will be able to understand, but try to calculate step by step so that you will remember the steps how to calculate. So next we'll move on to another problem. So here the signal to noise ratio is often given in decibels. Okay, signal to noise ratio, it is given in decibels. That means SNR dB. Okay, so instead of SNR, they have given SNR dB. Okay, so assume it is 36, and the channel bandwidth is 2 megahertz. Mega means 10 power 6 you need to take. So theoretical channel capacity can be calculated. Okay, so just write SNR dB is equal to, so because I cannot use SNR dB directly in the Shannon capacity, because the formula goes like this: B log 1 plus SNR. Okay, so I cannot use SNR dB here. So you need to convert this SNR dB to SNR. Okay, so what is the formula for SNR dB? It is 10 log SNR base 10. Okay, so now you just try to take the SNR. Okay, so you need to take the SNR to left side. So SNR is equal to 10 power SNR dB by 10. So you are going to get SNR is equal to 10 power 3.6. Okay, that is nothing but 3981. Just recalculate. Okay, whatever I'm doing, just recalculate in your calculator. So now I got the SNR, signal to noise ratio. Don't directly substitute SNR dB in the formula. So this is just an SNR. Okay, in case if they have given SNR in terms of decibel, convert to SNR using this formula. Okay, so now substitute. What is the bandwidth? 2 megahertz. Okay, that is 2 into 10 power 6 into log 1 plus 3981. Next. So you just calculate this. Okay, this is base 2 once again. So just calculate this. You are going to get 24 Mbps. Okay, just calculate and verify are you getting 24 Mbps or not. So when you are sitting for the class, keep notebook, pen and calculator. Okay. So this is another problem. Okay, so we have another problem. I think I will leave this problem to you. You just go through this problem, try to understand. Okay. So next, so using both the limits. So that means the Shannon-Nyquist formula and also Shannon capacity. So we can use these both the formula to calculate the bit rate. Okay. So that we can limit the signal level using Nyquist formula. So that is one advantage. So how many levels we need to fix to calculate the or to increase the data rate. So for that we can go with the Nyquist formula. So here Shannon capacity gives the upper limit. Okay, the Shannon capacity gives the upper limit, and Nyquist formula tells us how many signals levels we can use. Okay, it is not nothing like that. We have to go with either Nyquist formula or Shannon. So using both the formula, we can limit two parameters. One is using Shannon capacity, we can limit what should be the capacity of the channel, that is upper limit of the channel, capacity of the channel can be kept, and using Nyquist formula, so we can decide what should be the L value, signal level. Okay, so this is how we can use both the limits. So here there is one formula. So there you are going to limit the upper limit the channel capacity. So what is the problem they have given here? So we have channel with 1 megahertz bandwidth. Okay, they have given the bandwidth of the channel and they have given the SNR. So what is the appropriate bit rate? And okay, you need to calculate what is the appropriate bit rate and signal level. Okay, you need to calculate both C and also you need to calculate L. Okay, so first we'll go with the Shannon capacity formula because they have given the bandwidth and also SNR. You just substitute, you will get 6 Mbps. This is the upper limit of the channel capacity. Okay, even if you keep on increasing, there is no change because the bandwidth is not going to increase. So whatever the bandwidth that is there, only that much it can send. Behind that, it is not possible. So next, Shannon formula gives 6 Mbps as the upper limit. Okay, upper limit of the channel capacity. For better performance, we choose something 4 Mbps, for example. Okay, 4 Mbps, that is just a bit rate. Okay, I'm just considering, this is just for consideration. Okay, so then Nyquist formula, by if I am considering bit rate is 4 Mbps, I need to calculate what is the L value. Okay, so just substitute bit rate and find out what is L. So you're going to get 4. Okay, so this L value is going to indicate what is the correct number of signal levels we need to take. Okay, so here according to this bit rate, it is 4. Okay, try to solve this use calculator and know how to calculate this log 2, how to take L out of log. So just try to solve this step by step. Don't directly write the answer. In the exam, you will get confused. Okay. So this is a formula that shows always the Shannon capacity gives the upper limit, and Nyquist formula tells us how many signal levels we used. Okay. It is not like that we have to go with any one method. So both it is required. And the problems in the exam, there may be possibility they may ask the problems on these two. Okay. Nyquist formula, if they use noisy channel, it is understood you need to use Nyquist. If it is there is no SNR, if there is SNR, you need to use Shannon capacity. Okay, signal to noise ratio. Okay, so that finishes about the data rate limits. So next we'll move on to, are you people are understanding? Any doubts as of now? Any questions? Okay, if no doubts, I will go further. See, problems you need to solve. Okay, okay, problems you need to solve step by step. Okay, just don't read it. Problems to be solved. If anybody is having doubts, you can ask me in between. So now I'll just move on to the next concept. Okay, that is regarding performance. So how to measure the performance of the network. We have already discussed some of the parameters in the first chapter. So let's go in detail about these terms. Okay, performance always depends on these network parameters. One is, okay, so what is the meaning of performance here? What is the meaning of performance? What is the meaning of performance? So indicates how good is it? That is how good network, okay, how good it is. So to indicate the performance, so we need to understand some of the factors, that is bandwidth, throughput, latency. Okay, so in that we'll go with the bandwidth. Okay. So bandwidth, one of the characteristics that measures the network performance is the bandwidth. So in networking, we use the term bandwidth in two contexts. So now I told in the beginning of this class, so bandwidth can be expressed in two ways. So what are those two ways? So it depends on the context, to which context we are using bandwidth. So here one is representing the bandwidth in terms of hertz. Okay. And another one is bandwidth is represented in terms of bits per second. So what exactly the difference between these two? We'll just go one by one. So bandwidth, if it is in terms of hertz, okay, it is nothing but a range of frequency in a composite signal. Okay, it is a range of frequencies in a composite signal, or the range of frequency that a channel can pass. Okay, range of frequency means, so if it is the channel, okay, so what on all, there is a limitation, all the signals cannot be passed. So what should be the range of the frequencies it is going to pass? So that is indicated using with hertz. Okay, the unit used in this context, it is hertz. Example, bandwidth of the subscriber telephone line. Okay, if it is a telephone line, so normally we'll use 4 kilohertz. Okay, so 4 kilohertz. So like that, you need to understand in what context we are using the term. If it is telephone line, so we'll use in terms of hertz. Okay, it is nothing but range of frequency in a composite signal, or so bandwidth in terms of hertz indicates, so what are the range of frequency this channel can pass. Okay, So if you take radio, so you can just tune to different frequencies, no, in the same manner. Okay, so this channel can pass only few set of frequencies. Okay, so that range it is called as bandwidth. So that is one context. So next, the second one refers to speed of bit transmission in channel or link. Okay, so in another context, we'll use the bandwidth term bandwidth. So it indicates what is the speed of the bit it can transmit to the from one end to the other end. Okay, so refers to speed of bit transmission in a channel, how fast it can send the bits. Okay, so this is the second context. Okay, so depending on the context, either will be using hertz, bandwidth in terms of hertz, or it will be in terms of BPS. If you are talking about the particular line, okay, example telephone line, it is represented in hertz. If it is with respect to speed, okay, so how fast the bits can be sent. So in that context, we'll be using bits per second. So example for bits per second. So bandwidth of fast Ethernet network, Ethernet, okay, that is LAN network. So in this case, we'll be using in terms of bits per second. So for fast Ethernet, what is the maximum bandwidth? It is 100 Mbps. Okay, 100 Mbps, that is 100 megabits per second can be sent. Per second, 100 megabits can be sent in case of fast Ethernet. Okay, so you should remember this is the first method and this is the second method. So depending on the context, we'll be using the term hertz and bits per second. Okay, so next we'll move on to throughput. So what is throughput? So throughput, it's very important. Maybe normally in the network we'll use the term throughput. So throughput indicates how fast we can actually send the data through network. Okay, how fast we can send the data through network. Okay, so you cannot get confused with the throughput and bandwidth. Both are not same. Okay, the link may throughput and bandwidth are different. So link may have bandwidth B bits per second, that is bandwidth. Okay, so it is having B bandwidth bits per second, but we can send only T BPS. So using this link, T always less than B. Okay, so whatever say B indicates bandwidth. Okay, and T indicates the throughput. So always throughput will be less than the bandwidth, because this also we are representing in BPS. T is also represented in BPS. Okay, so the throughput is always less than the bandwidth. Okay, it cannot go behind, either it can be equal, cannot be more than the bandwidth. Throughput cannot be achieved more than the available bandwidth. Okay, so how much data it can send, it directly depends on the bandwidth. Okay, so one is either the T will be equal to bandwidth, or most of the time always, so T is less than B. Okay, T is always less than B. In other words, bandwidth is potential measurement of the link. Okay, so we are talking about the potential measurement of the link. But throughput is actual measurement how fast it can send. See, here what happens, whatever the bandwidth I have, okay, so I may not send the data in the according to that bandwidth. Okay, so there may be less transmission of data even though I have more bandwidth. Okay, for that there are a lot of reasons. So we may have a link bandwidth 1 Mbps. Okay, 1 Mbps, but device connected to the end of the link handle only 200 kbps. So it is not only depends on the sender, it depends on the receiver also. So how fast receiver is ready to receive it. If receiver is not able to receive at faster rate, obviously, so the throughput is going to be reduced. Okay, so even though I have enough bandwidth, see, bandwidth is 1 Mbps, okay, that is 10 power 6 bits per second. But due to the other end, what happens? The throughput is reduced to 200 into 10 power 3 bits per second. Okay, and also one more example what I can give here. So consider there is a highway. Okay, so the highway is designed to transmit thousands cars. Okay, 1,000 cars per minute. Okay, so whatever the highway they have designed, so that highway it can transmit 1,000 cars per minute from one end to the other end. So there are some end. Okay, consider this is single land road, so where it can cross 1,000 per minute. So they have planned to transmit 1,000 cars per minute. But what happens in real time? So if there is a congestion, okay, if there is a congestion, so there may be possibilities of the transmission of transmit of these cars can be reduced to 100. Okay, 100 per minute. Okay, it can transmit only 100 per minute. That is due to maybe because of congestion on the road. Okay, if any one particular car struck, so it may lead like that. Even in real time, there will be lot of issues arises when there is a communication. Okay, so especially congestion. So due to congestion, the throughput it is going to affect the throughput. It will reduce the throughput. So in this case, even though the road is designed for, okay, highway road is designed for 1,000 car per minute, but here the throughput what we are getting it is 100 car per minute. It can transmit only 100 car per minute. So this is how the bandwidth and throughput are related. Okay, is it clear? So we will try to solve some problems. Okay, so here the network with bandwidth, they have given the bandwidth 10 megabits per second can passes only average of 12,000 frames per minute. Okay, with each frame carrying, okay, frame means you need to understand it is once again a data. Okay, the data is represented in the form of frames. So each frame contains 10,000 bits. So what is the throughput of this network? Okay, you should be able to calculate what is the throughput of the network. So how many frames? How many frames? Totally 12,000 into, so each frame containing 10,000 bits. Okay, so here I am talking in terms of per second. Just divide by 2, you will be getting the, I am divide by 60, you will be getting 2 megabits per second. Okay, 2 megabits per second is the throughput of this network. So it is almost 1/5 of the bandwidth. So bandwidth is 10. Okay, you just observe bandwidth is 10. Sorry, but now throughput we are getting 2 megabits per second. So that means here the throughput is 1/5 of the bandwidth. So throughput here it is 1/5 of the bandwidth. Okay, always most of the time. So T always it will be less than B only. It cannot be equal or it cannot be more than B. That is the bandwidth of the channel. So are quite, I don't know you people are understanding or not. If any doubts you can just stop me. So next we have one more term. Okay, so that is called latency. So this is very important. So in networks we'll be using these terms: throughput, performance. Okay, ultimately the performance of the network is measured using throughput, and also what is the latency. That means what is the of reaching the message from one end to the another end. Okay, so either you can use the term delay or latency, both are same. So here what is latency indicates? So how long it takes for an entire message to completely arrive at destination from the time of first bit sent out of the source. Okay. So how much time it requires to send, how you're going to measure that? So when the first bit of that message leaves the source, so the time starts. Okay. And the complete message received at the destination, what is the time? Okay. So that total time taken, it is called as latency or the delay. So how you are going to measure this delay? Okay, for that we have different components. So the latency is equal to four components. One is called propagation time. Propagation time plus transmission time. We cannot just tell based on the distance. Transmission time, then queuing time, then processing delay. So these are the components. So we need to understand each of these components to calculate the latency. Okay. So what is propagation time? So propagation time can be calculated as distance. Okay, what is the distance through which the message is traveling? Distance over propagation speed. The propagation speed of the media. Okay, what type of media we are using? Propagation speed. So we'll just go with each of these terms one by one. Then later, after knowing these terms, if they are given all the values of these terms, you can calculate what is the time taken. Okay, so propagation time is distance divided by propagation speed. Okay, so what type of propagation media you are using. So accordingly, the speed of it is going to yes, mute yourself. Okay, I think I cannot complete this. I will just go with the propagation time. Remaining terms we'll discuss in tomorrow's class. Okay, the propagation speed of the electromagnetic signal depends on media, on the frequency of the signal. For example, what type of media they are using to transmit the data. So if it is vacuum, okay, in vacuum, the light is propagated with a speed of 3 into 10 power 8 miles per second. Okay, it is lower if it is the media is hair. Okay, so in case if it is cable, in that case also the propagation speed is going to vary. Okay, you can calculate this. I think I have not taken the problem here. So they have given the problem. I'll just read out. Listen. So what is the propagation time of distance between 2 points? Distance they have given 12,000 kilometer. Assume the propagation speed of the cable. Okay. So here they have given the speed propagation speed of the cable. It is 2.4 into 10 power 8 miles per second. Okay. So now knowing these two, you can calculate what is the propagation time. So to transmit the data, how much time it is taking? So distance is 12,000 into kilo. Okay, that is 1000. Either you can write it 10 power 3 or 1000 divided by 2.4 into 10 power 8. That's equal to, you will get almost 50 millisecond. Okay, you just calculate 50 millisecond it requires to transmit the data if this is the distance and this is the propagation speed. Okay. Okay, so just last topic, transmission time. So transmission time of message depends on size of message. Okay, size of message. See, it is not just, it depends on the distance and media. So if you go in detail, so even it depends on what is the size of message. Okay, so the transmission time mainly depends on the message size and the bandwidth of the channel. So in that case, you can calculate transmission time is equal to message size divided by bandwidth. So here what exactly the transmission time indicates, the first bit leaves earlier and arrives earlier. Okay, when it is transmitting, it starts with the first bit. So that is the first bit it is going to leave the system, and that is the first bit to reach the destination. So the last bit leaves later and it is going to arrive later. So that complete time, okay, so we call it as, that is sending the first bit to the destination and also receiving the last bit at the destination. So the total time we call it as transmission time. So this transmission time depends on what is the message size and what is the bandwidth of the channel. Okay. Okay. So you can, there is a problem for transmission time and propagation time. Will you go through this? It says directly you need to substitute and calculate. Okay, let me just go in brief about this. Okay, I think it will take time. Okay, tomorrow we'll discuss this problem and also queuing time. And we have one more small topic, bandwidth and delay product. Okay, and also jitter. There are 3 more parameters to be discussed. We'll discuss that part in tomorrow's class. So any